There are many components on a circuit board. How do we check if they're good or bad? For electrolytic capacitors, start by inspecting their appearance. If the top is bulging or swollen, just replace it. No need to test further. If the appearance is fine, then proceed. First, short the capacitor leads. If your multimeter has a capacitance measurement function, use that directly. If not, you can use the continuity, buzzer mode, or resistance mode to measure its resistance. If there is no short circuit, the capacitor is basically good. The battery is labeled as having a 3.7 volts DC voltage. If it drops below 2.5 volts, then it's faulty. Just throw away the 3.7 volt battery if it's below 2.5 volts. Either recharge it or discard it. For a working buzzer, it's very simple. Just supply it with about 3 volts or 5 volts, connect positive to positive and negative to negative, and briefly touch it with 3.7 volts. If it sounds, it's good. See, that's how you check if it's working. There's no problem with this. The rectifier bridge and the buzzer are both fine. The two middle pins are the power input pins. There's no short circuit there, and there's no short circuit on the two outer pins either. Alright, for this type of switch, if flipping it down disconnects it, then it's good. Pushing it up, that's also good. This one is also good. For this type, whether it's a transistor, a thyristor, or a MOSFET, as long as you measure and find that two pins are shorted, you can suspect it's faulty. But if none of the pins are shorted, it's basically a good power module. These two pins are for AC input, and they can handle anything from 70 volts to 270 volts. This is the output. My module here outputs 5 volts. Connect a 220 ohm resistor here, and let's measure whether it outputs 5 volts. Just test it and you'll know. If there's output, it's good. If not, it's bad. For the fuse, measure both ends with a continuity tester. If there's continuity, it's good. If not, it's bad. There are two ways to test whether the electronic lock is working. The first method is because there's a coil inside. When you power the coil, it pulls the magnetic core inward and the lock opens. If the coil is burned out, it will be open-circuited, and you can detect this using the continuity tester. So if this one is good, connect it to a power source and see if it activates. If it does, then it's definitely working. See, it activated, right? An inductor is very simple. It's also just a coil inside, so you still use the continuity tester. If you test it and there's continuity, then it's good. Alright, for resistors, we use the resistance setting to measure and check the resistance across its pins. If it's infinite, then it's faulty. This one is 10 ohms, which matches the main value indicated by the color bands, so this is a good resistor and not shorted. As for a good relay, the most common faults are either poor contact or failure to operate. You just need to apply power to the coil. And when you power it on, the copper piece in the middle will move. If it doesn't move, it's possible that the coil is faulty. If it does move, but the contact is unstable, you can use a multimeter to check whether the two pins are making stable contact and if there's any poor connection. Both sides of it are double switches. This is the common terminal, and this is also the common terminal. So whether it's powered or not, it will connect to this side or that side. It's like a relationship between a wall and a wall switch. Over here, these are actually the coil's pins. There's a schematic diagram here. Let's take a look. For the crystal oscillator, we don't need to remove it from the circuit board. If we have an oscilloscope, we can measure the waveform on these two pins. Generally, it will have an amplitude that looks like a band. If you don't have an oscilloscope, then use a multimeter set to the buzzer continuity mode. Measure both ends to check if there is a short circuit. For a good power module, just follow the instructions on it, input the specified voltage at the input terminal, and check whether the output terminal has the specified voltage. That's all you need to do. For example, this is also a capacitor, and it says 2.2 microfarads on it. The rated voltage is 1300 volts. Let's measure it. 2.16 microfarads. This one is good. For these capacitors as well, check if there is a short circuit. If there's no short circuit, it's generally good. If possible, we can use the capacitance range to test it. Check whether its capacitance value is correct and whether its ground value is correct. If the ground value is too high, then we just replace it directly. How do we test the chip? If we're testing by hand, we refer to the datasheet. First, measure whether the power supply and ground pins are shorted. Then check each pin to see if there's anything unusual in its resistance to ground. If there's something particularly abnormal or a short circuit, we can basically determine that it's faulty. For the 74 series or the 40045 series, we have specialized equipment that can directly test their logic. What about microcontrollers? Find its data sheet, understand the function of its pins, and check whether pin 49 and pin 29 are shorted. Then check this as well. Check whether the reset pin has a reset signal. We can use this. Using this oscilloscope, you'll see a transition either from high to low or from low to high. Then use the oscilloscope to check the 2 pins of its crystal oscillator as well. You can measure them. If the power, ground, reset, and clock signals are all normal, then check its data pins and ground pins to see if there's a short to ground or any particularly abnormal situation. For different packages, the pin positions will be different, the pin groupings. There are 2 types, A and B. For type A, it has a common terminal. The resistance between the common terminal and each pin is the same. For type B, every 2 pins form a pair. The resistance values are all the same. This is the type A pin group. There's a dot here which marks the common terminal. We use the resistance mode to measure the resistance between each pin and the common terminal. 1000. If you find that one of them doesn't have a proper reading or the measured value is significantly different in comparison to others, then it is highly probable that it is experiencing a malfunction.